This is the Mike Rosen Show on News Radio 850 KOA.
6 minutes after 10 o'clock, 303-713-8585, our telephone number. Since I just saw the Star Trek movie last night, and Greg Moody will join me Friday, we'll talk about that. It's probably appropriate to start this segment with the mission of the USS Enterprise to boldly go where no man has gone before. Incidentally, sometime during the series, they changed that to boldly go where no one has gone before. This was when the feminist movement started to flex its muscles, so the producers of Star Trek actually changed the wording. And I was curious to see in this movie whether they'd use the original to boldly go where no man has gone before or no one has gone before. Now, keep in mind that this is a prequel, so you see a very young James Kirk growing up as a boy, and then you see a young Captain Kirk. So I figured, since chronologically this takes place before the Star Trek series that we saw on television, that they would revert to boldly go where no man has gone before. But no, I didn't really believe that. At the end, it's boldly go where no one has gone before. So we're going to boldly go someplace where men and women haven't gone before, at least men and women as we know them. We're talking about the cosmos. We're talking about extraterrestrials. We're talking about interstellar travel and exploration and colonization. And our guest is Jeffrey Bennett. His book is Beyond UFOs, The Search for Extraterrestrial Life and Its Astonishing Implications for Our Future. Jeffrey's an astrophysicist, an author, and an educator, and we've got him here in the studio this morning.
Thank you very much, Mike. It's a pleasure to be here.
How can I be sure you are who you say you are and not an alien, in fact?
You cannot.
Okay, well, that's an honest answer. I'm suspicious, perhaps, that you have been planted here by aliens to mislead us.
That's always a possibility.
Okay.
Could be true of anyone else you know as well.
It certainly could. Now, should I even use the term alien? Maybe I should call them, if I'm going to use an abbreviation, can we say UETs, as in undocumented extraterrestrials? Would that be more politically correct instead of alien?
Well, there's certainly some people think they have the documentation. I still am in the undocumented
I was just
camp.
talking about the terminology here.
So I think that'll work.
Where do you educate?
I taught at the University of Colorado for more than 20 years, and now I'm a full-time writer, but my primary writing is college-level textbooks, so I'm educating that way.
What did you teach at CU?
I taught astronomy, math, physics, and education.
Oh, okay. Well, you certainly have the credentials. And I have to say the book is very readable for people who aren't necessarily astrophysicists themselves. Rather than start at the beginning, let me start toward the end of the book. And you describe the paradox and then give three possible major categories that we could consider in trying to wrestle with the paradox. First of all, what is the paradox?
Well, the paradox is that we live in a universe that's quite large. It's filled with lots of stars that we now know have lots of planets. And so if life is something that we expect to be common, and there's a lot of reasons why throughout the rest of the book I talk about why we would tend to think life should be common, then you would think that someone else like us would already be visiting us or have made contact with us. And yet, aside from UFO reports that aren't yet to the level of evidence that scientists have come to accept, aside from that, we don't have any hard evidence that aliens are actually here. So why not? That's the paradox. It seems like they should already be here, and yet we don't see them.
So let's talk about the three categories.
The three categories, the first is that the reason we don't have this evidence of aliens is because they're not there, because despite whatever ideas we might have from science about how likely it is to find life, there's something we don't know yet, and in fact, life is very rare, civilizations are very rare, and we're the first ones out there, and that's why we have not
The first and the only.
The first and the only. So that's the we are alone possible
in
answer.
our solar system, in our galaxy, in the cosmos, in infinity, we are the only sentient life form.
That is that possibility. Now, personally, although it's certainly scientifically possible, I find it rather difficult to accept because, as I talk about elsewhere in the book, For example, the number of stars in our universe is greater than the number of grains of sand on all the beaches on Earth.
And by
combined.
stars, we mean suns
that
with planets
could
around
have
them.
Planets around.
Solar systems, like every time you see that little pinpoint of light, that's
right.
another solar system.
That's right.
Unless
so
it's a planet.
It seems difficult for me personally to believe that we'd be the only ones with such an immense number of possibilities. But we can't rule it out. It's one of the three possible answers.
All right. When we look at our solar system and take a look at the temperature variations and whether or not there's water on these other planets in our solar system, you might conclude that we are the only planet, Mars has been mentioned as a possibility, that could host life as we know it. Let's just stay with that for argument's sake. In that vast cosmos, there must be other solar systems that are similar to ours, with planets similar to Earth in relation to its sun. Yes?
It certainly seems that way. We don't have the proof yet because we haven't observed them. But yes, I would argue that that is highly likely.
Is the cosmos infinite?
Well, the cosmos may or may not be infinite. We don't know, and we may never know. What we do know is that the portion of the cosmos that we can in principle detect is finite, because it's limited by how far light can have traveled in the time that the universe has existed.
So if it's finite, what's on the other side of it?
Well, if it's finite, then
is it a big box?
It's not a big box. Presumably, there would just be more of the same on what we would call the other side. So in other words, it's like speaking. If you have a sound wave going out from your voice, after a certain amount of time, someone a mile away will have heard it and know you're there. Someone 2 miles away will not yet have heard it and therefore doesn't yet know you're there. And it's the same thing with light. The universe has a finite age, and therefore there are things for which the light has had time to reach us, and we know they're there, and there are things that are too far away for the light to have reached us yet, and therefore we can't tell that
this is
there.
Very, very difficult for the human mind to grasp, isn't it?
The concept of infinity or even very large things is extremely difficult for us to grasp.
Somebody once said, all this talk about infinity, where's it going to end?
I like that.
I don't have the answer to that one either. So the universe, by definition, is the universe all included, or can there be more than one universe?
Well, in science, we define it in several ways. First, we have what we call the observable universe, which is that portion that we can in principle see today. The light can have reached us since the time the universe began. Now, the universe probably extends well beyond that observable universe, just like that echo example I gave you, but those are parts that we cannot observe directly. In recent times, physicists have started to talk about this multiverse idea, in which there would actually be other universes. And by other universes, they mean universes that might have different sets of physical laws, different types of matter that is not made out of atoms, and so on.
Different dimensions?
Different dimensions is a possibility as well.
All right, so we considered the one major category, we are alone. What's the second major category?
So the second major category, and remember now we're talking only about our observable universe, which still has that enormous number of stars, just like grains of sand on the beaches of Earth. The second category is that there are lots of civilizations out there, but for some reason they have not come and visited us or made contact with us in any way. And that's certainly a possibility, but then you would have to ask yourself, if there are lots of civilizations and they haven't come to visit us, why not? And of course, one possibility would be they just don't feel like it. But if we look at human history and assume that there's going to be at least some of them that would be somewhat like us, we have always explored. People have debated whether exploration is a good idea or not, but in the end, we've always gone out and explored. So you would think the same would be true of other civilizations. So it's difficult to accept the idea that they don't feel like it. We have to assume that if they're out there, they would want to explore. And so the next possible subcategory that goes with this, that there's lots of them and they haven't come here, is it's because they've destroyed themselves before they got the capability for interstellar travel. And certainly when you look at where we are as a civilization with nuclear weapons, terrorism, environmental issues, and so on, the possibility of us destroying ourselves before we get Star Trek capabilities seems very real. We hope it won't be the case, but that is one possibility, that the reason we don't see all these other civilizations out there is because they never survive long enough to go out and visit others.
Which raises an interesting philosophical question. And since all we can talk about with any knowledge is humanity as we know it, and human nature as we observe it, is it human nature that a civilization like ours will ultimately destroy itself?
Well, according to the second possibility, the answer, if that were the true answer, it would probably be yes. But we hope that that second possibility is wrong. So that's where I think the most astonishing implications of this whole discussion take us, is the first possibility, we are alone, seems highly unlikely when you consider the numbers. The second possibility, that they all destroy themselves, well, that could be more likely, but we want to hope it's not true, because we want to hope we can survive too. And that leaves us with the third possibility, which is that there's lots of civilizations out there. They have survived. They are millions to billions of years older than us. And there is a galactic civilization out there already, much like what we see in the movie Star Trek. And they are only reason we have not made contact with them yet is because they haven't felt the time is right.
Now, if we're not alone, and if there are other civilizations, and if the universe is very, very old, so old that I can't even contemplate how old it is, and if these other civilizations haven't destroyed themselves, then thinking about this huge span of time, it would seem likely that somebody would have explored this far to find us.
And I would presume that they have, but that doesn't mean that they would have made their presence obvious to us. I like to think of it in terms of Star Trek with the Prime Directive. Maybe they have a Prime Directive. Don't interfere with emergent civilizations like what we have here right now. And so in that case, it's a matter of time until we do eventually get contacted by them, but that could explain why we have not made that contact yet.
How about the notion that the kind of travel we're talking about, the kind of interstellar, intergalactic travel, isn't possible?
That is something that some people have talked about, but I put that in the same category as the people who used to say you'll never break the sound barrier and you'll never go to the moon and so on. Every time we've said, oh, there's some technological barrier or something, it's turned out that we find a way around it. So people do make arguments like that. They say, oh, the energy requirements for interstellar travel are so great that nobody could ever get that much energy. But, the sun makes a lot of energy. If we figure out ways to tap some of that energy, we could easily do it. So I don't think that we are going to be stopped by the technological difficulties.
How fast do you have to go to get from one galaxy to another?
Well, we're talking about stars within our galaxy, not from one galaxy to another. But you have to go. The distances are incredible. 4 light years is a huge distance, but it's only to the distance to the nearest star. And to give you an example of how far it is, the spacecraft like New Horizons that's on its way to Pluto right now, traveling at about 50,000 kilometers an hour, 30,000 miles an hour, that's 100 times faster than a bullet is fired. It's the fastest thing we've ever built. And at that speed, it would take it 100,000 years to go those 4 light years. So if you want to get that distance in a reasonable amount of time, you have to be going much, much faster, close to the speed of light. If you could get close to the speed of light, then it would take you around 4 years to go those 4 light years.
In this latest Star Trek that I saw last night, when they go to warp speed, they got from the planet Vulcan to Earth in 3.5 minutes or something like that.
Correct.
Have you seen the movie?
I haven't seen it yet. I can't wait to go. I'm a big Star Trek fan.
How fast is warp speed?
Warp speed is made up so it can go as fast as you want. It's in Star Trek lingo, it's some sort of a power law multiple of the speed of light. But the idea behind warp speed and hyperspace in Star Wars is a similar idea. I love to tell my students when we're talking about relativity that not even science fiction writers try to say that Einstein was wrong about not going faster than the speed of light. What they do is they look for loopholes, and warp speed and hyperspace are both ways of essentially leaving our ordinary universe and popping back in where you want to. And where you want to can be close enough in time to when you left that you can seem to have gone a great distance in a very short amount of time, but you didn't actually travel through that space. You warped it or you left it. So it's a science fiction device that may or may not be possible in real life. We really don't know at this point.
As I'm watching the movie yesterday, Star Trek movie, when they pop into warp speed, it's like going from 0 to 60 in a nanosecond. And what occurred to me, I remember when I got a cat shot off of an aircraft carrier. And you go from 0 to 200 miles an hour in an instant on this propelled catapult. And you feel a force of about 9 Gs. when you're going from 0 to warp speed, it would seem to me that would be 80 million Gs. You'd implode.
That's exactly right. Believe it or not, the Star Trek writers over the many decades have come up with all sorts of possible physics ways of getting around all those lethal things that they would be suffering. And they always do it in a great way where they don't violate any of the known laws of physics, but they use some ideas that we don't know whether they're true or not. So it's fun. You can read books about that, Star Trek literature that'll tell you how they avoid dying when they go.
You know what somebody's face looks like when they're in a cyclotron,
Yep.
feeling all those Gs? Going from 0 to warp speed would be much, much more pronounced than that.
That's right. So
But
they
they
have to
don't
come
deal
up
with
with some
that.
clever little physics thing to counteract it. And I don't recall the details of it, but you can actually find that if you look through Star Trek literature.
All right, 11:21 the time. Jeffrey Bennett, our guest, his book Beyond UFOs, right back on News Radio 850 KOA. 10:26 the time. Jeffrey Bennett is our guest. He's an astrophysicist. For years, he taught at the University of Colorado. He's an author. His latest book is Beyond UFOs, The Search for Extraterrestrial Life and Its Astonishing Implications for Our Future. Let's talk about UFO sightings and actual I shouldn't say UFO beings, alien beings, people who relate these experiences with them. First, the UFO sightings. Are you skeptical? Are you credulous?
Well, it's an interesting question. When you get to just the straight sightings, they have all the characteristics of what you might expect from an extremely advanced alien civilization that has technology that basically we can't detect. But maybe every once in a while they slip up enough that you get a quick glimpse, you see something, and then it's gone. Beyond that, in terms of claims of hard evidence, aliens dropping parts and so on, those things I'm pretty skeptical of. But the sightings themselves, I'm skeptical in the sense that I wouldn't necessarily say I think somebody actually saw an alien spacecraft, but on the other hand, it's a reasonable possibility for what they might have seen.
And why would they, whoever they are, come all this way, just kind of take a glimpse at us and leave?
Well, I would say in this case, they're probably not just taking a glimpse. They might be studying our planet, and we only got a glimpse if that's what's going on. But, we study everything we can find, and so I would think that if they know this planet exists and has life on it, they'd be interested in studying it.
And they've emplaced people here, and you might be one of them. We've already discussed that, so I've got an open mind on that. Why do you say that most of the claims people make about supposed visits don't make any sense?
Because they have the wrong level of technology. If you think about the level of technology that it takes to get here and what alien civilizations must be like, they shouldn't be at all like where we are technologically. In the book, I go through the time argument of why they should be at least 50,000 years ahead of us if they're able to come here, not to mention the incredible distance that they're traveling. And so if you just take that 50,000 years and think about what they have, they're going to be technologically, in principle, where we would be if we kept developing our current technology for another 50,000 years. And given that 50 years ago people didn't even know the internet was coming, I don't think we can predict where we'll be in 50 years, let alone in 50,000. So if you see them dropping parts and they look kind of like metal or some other material that we're using today, that's not what someone 50,000 years beyond us would be using. So that's why a lot of these claims to me don't make sense. They are things that look like us, not like someone 50,000 years beyond us.
When you see movies like Star Trek or Star Wars, the way aliens are portrayed, many of them have obvious humanoid features. Others, well, I don't have to describe them. You know what they look like as well as I do. Would we have any reason to believe that aliens from other solar systems would look anything like us?
Well, probably not directly, but there might be some things that you would expect in common. For example, dolphins are pretty smart, but you're not going to find dolphins traveling through space because they don't have limbs to build spacecraft with, even if they're smart enough to do it. And so there's certain requirements if you're going to be traveling through space. You got to be able to put things together. You have to be able to see. You have to be able to hear, sense the environment around you. So there's going to be at least some similarities to us, whether that would have to be 2 limbs, 4 limbs, 10 limbs, 2 eyes, more eyes. Those are all things that, we can't say.
How about intermarriage between aliens and Earthlings?
Well, given that it's not possible between different species on Earth. It seems highly unlikely that it'd be possible between different species in the cosmos. But of course, if you remember one of the Star Trek movies from a number of years ago, they actually explained that by going back to how we were all seeded from the same.
Well,
original.
Kirk certainly experimented with that kind of thing on many occasions, did he not?
Yep.
So what kind of a marriage ceremony would they have? Since they probably have a different religion, they'd probably have to have a civil ceremony of some sort, don't you think?
Or they just do both.
Okay. Let's talk about relative size. You've got some good examples here, putting it in terms people can understand. The size of the Earth relative to the Sun, the distance of the Earth's orbit around the Sun. Give us some examples.
Well, I like to use a scale of 1 to 10 billion, which is the scale we built the Colorado Scale Model Solar System on, that you can see up at the University of Colorado campus in Boulder. Starts outside the planetarium there. And we also have one in Washington, D.C., and I'm working hard to try to bring one to Denver. So if any of your listeners want to help out with that, let me know. And what we do is we have the Sun on that scale is about the size of a large grapefruit. And on the same scale, Earth is about the size of the ballpoint in your pen, and it's orbiting about 16 yards away from the Sun. So that gives you a little picture of Earth and the Sun in comparative size.
16 yards diameter.
16 yards away from where the Sun is. So you have, yes.
So 32 would be the diameter.
Of the diameter of Earth's orbit on that scale, right. So you imagine walking in a circle that is 32 yards in diameter with a little tiny ballpoint from your pen, and that's what Earth's orbit is like.
And it takes you a year to
It takes you a year to go all the way around. And on that same scale, it's about a third of a mile to Pluto, and it's about 2,500 miles to the next star. So it gives you right away a sense of how incredibly far the stars are compared to the planets in our own solar system.
What was your take on the downgrading of Pluto from a planet to whatever it is now?
Well, it's a semantic issue. Pluto hasn't changed at all. But what we did find out over the last couple of decades is that Pluto is like a lot of other small bodies that are out there, and it's part of the solar system. And in 2005, we learned it's not even the biggest of all those small bodies floating around. So the astronomers had a bit of a crisis. They had to decide either that there were more planets than 9, because there was at least one that was bigger than Pluto out there, or they had to demote it. And the vote was to demote, but it doesn't make it any less interesting scientifically or any less important to us.
Did Pluto get a chance to appeal the demotion?
Well, in fact, there is a whole group of scientists who do plan to appeal the decision at this year's meeting of the International Astronomical Union. It's held every 3 years, so it was 3 years ago that it was voted down, and it'll probably be voted on again this
Well, who represented Pluto, though?
Alan Stern, I think, a friend of mine.
You'd think a Plutonian would be there, or at least Pluto could call Mickey Mouse and Donald Duck as character references.
Yeah, sure. Alan's the PI on the New Horizons mission, so he feels pretty strongly about it.
All right, let's take a break. When we come back, we'll take some phone calls, and also let's talk about the creation of our planet and the contradiction or confluence between the biblical creationist theory and evolution and the Big Bang, and bring all that together for us in 2 or 3 minutes. I'm sure there won't be any problem at all. Right back on News Radio 850 KOA. Jeffrey Bennett, our guest, his book, Beyond UFOs, The Search for Extraterrestrial Life and Its Astonishing Implications for Our Future. Let's take a phone call. Jim in Denver, you're on 850 KOA. Jim, you're about to ask just the question I was going to ask, so let's have you ask it.
Yeah, I was wondering if you could give kind of a layman's explanation of the Big Bang Theory.
Well, the Big Bang Theory is, it's got a strange name because it probably was not an explosion of any sort. But really all it is that we see the universe expanding today. By looking out there, we find that the universe is growing larger with time, by which we mean the average distance between galaxies is getting bigger. So if you work that back in time, it means they were closer together in the past. And if you look at how far apart they are now and how fast they're moving apart and work it backwards, you'll find that about 14 billion years ago, they would have all been on top of one another. So that must be when things started expanding. And that's what we call the Big Bang. So the Big Bang is just the idea that the universe had a beginning when the expansion started.
But there was something there before the Big Bang occurred.
Well, that's a good question. Under our normal viewpoint of it scientifically, the way that Einstein's general theory of relativity tells us, the Big Bang and the universe, what we're talking about is space and time together. So there is nothing outside of that universe. So there wasn't anything there until it began expanding. That's a very strange concept.
And this is the one that I've never found it possible for me to grasp. Whatever happened at the Big Bang came from something. There was some catalyst. There was something that caused it to bang. What was that?
Well, that's actually a major point of debate in science. Actually, it's not really science. It's more philosophy, because we can't study that at this time, and science is restricted to what we can actually study. But basically, if you take one viewpoint on it, since the universe includes time, there is no such thing as before the Big Bang. But there are other scientists who think, well, maybe there was, and there is some sort of causation to it. The problem is we cannot actually study the very instant of the Big Bang. We think we can study back to very early during that first second by reproducing some of those conditions with things like the Large Hadron Collider in Switzerland. But we can't get all the way back to the beginning, and if we can't study it, then it's not science.
It's beyond science to
It's metaphysics.
Right.
Yeah. Okay, that in some ways that kind of drives my faith that there's more going on than what appears, to us.
Oh, okay. So how does science then connect, or does it, with creationist theories, supreme beings?
Well, I think if you're looking at that as a general question, science and God, I think the answer is that science and God they don't interfere with each other at all. And that's why there's plenty of scientists who are religious, plenty of religious scholars who study science, because science can only take us back to the things we can actually observe. And as your caller just said, there's certainly more going on than we know about scientifically right now. And the only question is that part that we don't know about scientifically, is that God? If you're religious, that's your viewpoint. Or you might take a viewpoint that it's something else, but we don't know what it is either way. So there's no conflict between science and God.
Can creationism and evolution, as it's occurred on Earth, coexist?
It depends on exactly what you mean by creationism. If you mean the idea of God being there, then yes, absolutely they can. If you're talking about saying the universe is 6,000 years old, that's different from what the scientific evidence shows. That doesn't mean you can't believe it. It just means if you believe it, you're not doing science.
Well, the gulf between the creationist view and evolution is one where the creationist view skips a number of steps that are essential if you want to be consistent with evolution. Under the creationist explanation, man in its present form, or pretty close to its present form, was created right there. It didn't evolve from earlier forms. That's where there'd be a contradiction, presumably.
Well, that is one viewpoint of creationism. It's an interesting thing because creationism is taken from the Bible, and as we all know, even among Christians, there's great difference in how that's interpreted. The Catholic Church, for example, has not seen a contradiction between evolution and a literal reading of the Bible. Other churches have found what they think is a contradiction. So it's a question of how you perceive and how you read the Bible for yourself as to whether you think there's a contradiction there.
How does the Catholic Church then square that circle between your notion of evolution, your sense of evolution, and a literal interpretation of the Bible?
If I recall the quote from Pope John Paul, it was that basically the Bible is the literal word of God, and science is also correct, and that if we see a contradiction there, if we see what seems to us to be a contradiction, it's because we're not as wise as God. And that was the way John Paul looked at that issue. And there are, the Catholic Church for quite a long time has accepted evolution as well as the Big Bang, and there's many Catholic priests who are also scientists who study these things and believe both that the Bible is literally true and in evolution.
Ron, you're on News Radio 850 KOA. Hello, Ron.
Hey, how you doing?
Good.
Hey, I got to ask your guest something. Do you think that if we could travel and stuff and they have these warp speeds and things, that if we did find life, we might be disappointed on some planets? If we see that there's life, it'll be lichens, pond scum, plankton, and that'd be about it.
Well, I would say that we would probably expect that most planets that have life out there, that's about all we're going to see. And we can come to that conclusion just by looking at the history of life on Earth, in which it was basically that kind of stuff for the first almost 4 billion years, and it's only in the last few 100 million years that we've gotten complex plants and animals. So if you go out and pick some world at random anywhere, you're going to probably find only primitive life. But the numbers are so great that there should be some that have advanced life as well.
Oh, I agree with you. And the other thing, you were talking about the Catholic Church and the Jesuits working with the Vatican have, and you probably know this, have one of the most advanced astronomical observatories in Houston. Not Houston, I mean Tucson, a mountain near Tucson, Arizona.
That's right. There's a very long history of them doing science. In fact, one of the originators of the whole concept of relativity and the Big Bang Theory was a Jesuit Catholic priest.
All right, thanks for your phone call. Kind of disappointing for Captain Kirk to come to some new world and find only bacteria and pond scum. Who would he date?
That's right. That's right. He skips those worlds.
Let's go to Jay. You're on News Radio 850 KOA. Hello, Jay.
Hi, Mike.
Hi.
Say, I agree with you on the fact that it's kind of inconceivable, really, that where time actually began, because I, like you, can imagine that what happened before that, who created God, who created that, and when can you conceive the end of time? Can you conceive the end or a beginning of a straight line shooting out into space? It's not possible that a human being has enough brain power, even Albert Einstein, to conceive some things that makes up the total existence of infinity.
Well, your difficulty in explaining this, as mine would be, is witness to that. I think Isaac Asimov once said, any God that can be understood is no God.
And Einstein said that the most incomprehensible thing about the universe is that it's comprehensible. What we don't know is how far that extends. Is it fully comprehensible, or are we going to eventually run up to limits of our scientific knowledge?
And how can we answer those questions if we haven't ever answered the question of what do women want? Right back on News Radio 850 KOA. 10:54 the time. Beyond UFOs is the name of Jeffrey Bennett's book, The Search for Extraterrestrial Life and Its Astonishing Implications for Our Future. For many years, did you say 30 years?
More than 20 years.
More
I was
than
teaching
20.
up there.
Jeffrey taught at the University of Colorado. He's an astrophysicist. Let's go back to the phones. Dave, you're on News Radio 850 KOA. Hello, Dave.
Hello, Michael. Hello, Jeff.
Hello.
So the question, as I understand it, you're talking about the Big Bang. When the Big Bang or a movement happened, it actually had to create its own space in which to move, correct?
That's correct. Space is growing, and it's being created in that sense as the universe expands.
So then, essentially, the space, whatever this movement was, is still creating more space as it moves along.
That's correct.
And then, take that a little bit further, when we're this is where my mind wants to boggle.
Mm-hmm.
How has anyone created a mathematical formula to consider nothingness, as the Buddhists like to talk about, consider nothingness into which everything comes from?
I'm not sure it's quite exactly like that, but yes, there are mathematical formulas, physics formulas that describe the state of the vacuum, the empty space. They describe how space grows. That's Einstein's general theory of relativity.
So
things like that.
When you get to the end of space,
well, you don't.
Oh.
You would just keep going if you could. It's only limited by how far light has traveled. If you don't mind another plug here, Beyond UFOs, I hope everyone will read it, but it's about the search for extraterrestrial life. But I do have another book that talks about all these things called On the Cosmic Horizon. Mm-hmm. And I go into a lot of detail about what we mean by an expanding universe, the evidence for the Big Bang, and what's going on, and would answer all of these questions.
So there's never any point I get to where, to use an analogy, it's like a ski area boundary where there's a sign and a little rope saying you can't go beyond this.
Correct. You never get to that.
Yeah, I think it was actually, you'll know this, Jeff, I think it was maybe Pythagoras 2,500 years ago said you could travel to the edge of the universe and then throw your spear into the other side of it.
There are ideas like that. We usually, in science, and if you look in my book On the Cosmic Horizon, I use this a lot. We use an analogy for the universe as the surface of a balloon. so that if you keep moving around the surface, you never come to an edge, just like you never come to an edge on the surface of the Earth.
Okay, let me tie something else in. The Hadron Collider under Geneva or under Switzerland and France. They're planning. Well, they tried to get it working, 6-9 months ago, whatever it was, and it failed. And they're going to bring it up again. What are they looking for specifically with this collider?
Well, part of what they're looking for is just to reproduce higher energy conditions than we've ever been able to produce in the lab before and just see what's there. A lot of basic science is you just say, well, what would happen if? And this is the if in this case is if we gave it even more energy than we ever have before. There are certain types of particles that are predicted to exist by our current theories. And therefore, if the theories are correct, then they should find these particles. If they don't find these particles, then we'll have to go back and revise the theories.
Okay, and then Einstein's equation, E equals mc squared. How can we go about reversing that, taking the mc squared, mass times the speed of light squared, to create energy?
Well, that's what nuclear reactors and nuclear bombs do. They turn the mass into energy. It's also what the sun does. The Large Hadron Collider does the reverse. It takes energy and turns it into little particles of mass.
All right.
Okay.
Dave, getting
wait, one more question, Mike. And the
Yes.
answer to what do women want?
Yes.
They want to keep us guessing.
Okay. All right. Fair enough. I think I already knew that, though. Mike, you're on News Radio 850 KOA. Hello, Mike.
Hello.
Yes.
You talked about measuring the rate at which galaxies expand from each other, and I'm gonna create a visual and tell me if I'm wrong with this. But if everything's expanding outward, if we took a cross section of that and imagined it like a pizza in slices, so that would be that's a 2-dimensional slice of a 3-dimensional expansion, I guess. How do you decide whether a galaxy's
Mike, I'll tell you what. I'll put you on hold. Jeff, are you able to stay over into the next hour?
Sure. I can stay for a while, yep.
Okay. Mike, keep that question in mind. I'll give you a chance to re-rack it when we come back after the news. And since obviously the question still had a minute or two to go, the answer would take several minutes more than that. Right back on News Radio 850 KOA.
This is the Mike Rosen Show on News Radio 850 KOA.
6 minutes after 11 o'clock. Welcome back for our third hour on this Tuesday, the 12th of May. Thank you for joining us. Jeffrey Bennett has been our guest for the last hour, and Jeffrey's able to hang over for about a half an hour into this one. His book is Beyond UFOs, The Search for Extraterrestrial Life and Its Astonishing Implications for Our Future. Jeff is an astrophysicist. He taught at the University of Colorado for 20 years in that discipline, and the author of some other books as well, including some kids' books. Before we go back to Max, who had a question that we put on hold during the news, maybe you could tell our listeners a little bit about your kids' books.
Well, my kids' series is Max Goes to the Moon, Max Goes to Mars, and Max Goes to Jupiter. So these are books where my dog Max goes off to these places and teaches kids. He just goes and has his adventures, and on the sides of the pages, we actually explain all the science that's going on behind the scenes in the story. So the kids can enjoy the story and the adventures, but they can also learn a lot of real science as they go through.
Coffee table size book with colorful pages, glossy, colorful pages. Very nice. Max Goes to the Moon. Where did he find a fire hydrant on the moon?
We skipped that part of the story, but that's for the kids' imagination.
All right. He doesn't do it in his spacesuit, does he?
He must.
Well, that's what the astronauts do, don't they?
That's right.
I couldn't live like that. 713-8585, our telephone number. Max, you were drawing your analogy with a pizza pie.
Yeah, it's Mike, not Max is his dog.
Oh, that's right. Okay, excuse me. It does say Mike. And by the way, before you get into that analogy, now here seems to be a good example of where scientific theory held for a while, then was proved wrong, and it was changed. And by that I mean, I learned in high school, probably in geometry class or trigonometry, they taught me that pi r square, and I know that pi is round. So originally we thought that pi was square, but we learned that it was round, and we changed that theory, right? Are you following that, Mag?
Yep.
Okay, go ahead. Give us your analogy.
So with these calculations of measuring the expansion of the universe, do you have a way of telling whether you're looking at a galaxy across the other side of just a cut crust, the wedges, or if you're looking at something across the other side of the pie altogether, that distance? And if you can, is there a way to figure out where you think the center of all this used to be?
Yeah, I think that the problem is your analogy is two-dimensional, and you have to go beyond that. So the analogy that we use, again, is that surface of the balloon. So if you imagine the surface of the balloon expanding and that the universe is only the surface, not the inside, not the outside, then if you draw dots on that balloon as you blow air into the balloon, the surface of the balloon, which is your universe, you'll see the dots getting farther apart from one another.
Okay.
It doesn't matter which dot you pick. Wherever you are, if you look out, you'll see all the other dots moving away from you. So you can't say that any one dot is any more central than any other, just like you can't say New York City is more central to the surface of the Earth than Beijing or something. It's just the surface. Everything is equivalent in that sense. So no matter where you are in the universe, you'll see the same thing, or you'll see all the other galaxies moving away from you, and you can measure their rate, and that's how you figure out how fast the universe is expanding.
That makes sense. I was just thinking that if you could find a set, then you might be able to look at some sort of progression of age,
Yeah, so the next time you use that analogy, if you want to use the pizza pie analogy, don't use a thin crust pizza because that would be two-dimensional. You'd have to use a thick crust pizza, which would be three-dimensional.
But there is another good point you just touched on there, is that we do have a way of seeing age, because remember, light takes time to get here. So the further away you look in space, the farther back in time you're looking. So if you see a galaxy that's, say, 10 billion light years away, you're seeing it the way it was 10 billion years ago, when the universe was much, much younger than it is now. So by looking at different distances, you can actually reconstruct the history of the universe, because you're seeing the universe at different stages in its existence.
Okay. My thought was that if there's going to be a shot at finding some sort of development, the farther back you look, the better chance you have of that working out, I would think.
Maybe not. It might be the opposite of that, because if you look to places very far away, you're seeing them as they were a long, long time ago, which means there was less time for life to have arisen and developed. So you're more likely to find it around here.
Day setting. You're right. Okay.
All right, thanks for your phone call. When you used your analogy earlier, Jeff, about a football field and the relative size of the sun and the earth, that's kind of a two-dimensional analogy, because we think of a football field as a flat surface. So we know how long our solar system is, but how deep is it?
Well, interestingly, all the planets orbit the sun in about the same plane. So that flat analogy is a pretty good one for the orbits of the planets. Now, the thing that doesn't orbit the sun that way is comets. The comets come from a spherical distribution that goes way, way out. But the planets all go in the same direction in the same plane, and that's actually part of the evidence for how we think the solar system formed, from this spinning cloud of gas that would have spun like you spin a pizza dough. It all flattens out into a plane, and that's when the planets form. Therefore, they're orbiting in that plane.
All right, so we have our solar system, and then the next closest solar system. Is there an overlap? Is there a space in between solar systems? And what's that space between solar systems?
Well, that's interstellar space. And yes, it's huge, because, again, remember, we take our sun the size of a grapefruit. You reach Pluto in just a third of a mile. To get to the next sun, Alpha Centauri, you have to go 2,500 miles, the distance across the United States. So it's a gigantic gulf between one solar system and another. And that's interplanetary space, where there's, bits of dust and gas, but that's it.
Do any solar systems overlap?
No.
Why can't they?
Well, the distances between the stars is far too great. The only place where you would have that possibility would be if you had two stars orbiting each other closely, and those are called binary systems, and there's lots of those, but we would not expect orbits to be stable if they were trying to overlap. They'd either have to form an orbit around both stars together, or an orbit around one star very close, so that it's not interfering with the other star.
Okay, let's go to Stan in Lakewood. You're on News Radio 850 KOA. Hello, Stan.
Gentlemen.
Yeah.
I ask forgiveness, as every time I think of this subject, it gives me agita.
I know exactly what you mean. I had the same problem yesterday watching Star Trek.
I know, sir.
Yeah.
Infinity and somewhat mass. What came first? what occupied the space previously? Everything we know in life has a finite being. How do we get beyond that? What was beyond that? What is beyond that?
When you say a finite being, you're talking about a finite space that it occupies, or a finite beginning and a finite end?
Both. If you look at Coca-Cola in a can, well, it was in a vat before it was in the can. The ingredients were elsewhere before it was in the vat.
You talking about Diet Coke or regular Coke now?
Regular.
Okay.
I'm a regular Coke guy.
But it's an excellent question, and if you put that in scientific terms, we're talking about the law of conservation of energy and the idea that energy and matter don't come from nothing. You can always trace them back. You can trace that Coke back to the ingredients it came from. You can trace it back to the matter that was produced in the Big Bang. But eventually, you do reach that point where you say, okay, but it all came into existence 14 billion years ago with the Big Bang. That violates the law of conservation of energy because it had to have started.
What was there first?
So that's the question. What was there first? And so that's the question that scientists would love to know the answer to, but we don't know the answer to it. And at the moment, we don't really even have a way to investigate the question scientifically. And one of the, I think, very important messages I want to get across with Beyond UFOs and my other books is the difference between science and other forms of thinking about the world and knowledge. In science, the only thing we can do is what we can actually test and experiment and observe. If it's something we can't do that with, it's not science. So the question you're asking for the moment is not science until or unless we someday find a way to study it.
Hence the agita.
Okay, thanks for your call.
Thanks.
Let's go to Greg in Englewood. Jeff Bennett, our guest. Greg, what's your comment or question? What's on your mind?
Hi. Great show. Love it. Have you looked at data that points to a younger universe, such as the polonium-214, the moon dust, the recession rate of the moon, and the the Roche limit, and the that scientific data that might point to a different theory of a younger universe?
Well, there's all kinds of data out there that people study, and no one person can look at it all, so I can't say that I've personally looked at that stuff. But the way science progresses is that we have lots of people looking at the data. Someone comes to a conclusion, someone else challenges their conclusion, and we keep looking and try to see if we can understand it. And at the moment, the preponderance of evidence is incredibly strong that the universe is expanding, has been doing so for 14 billion years, which implies a beginning 14 billion years ago.
Yeah. I read this article on polonium-214, and it's really been a craw in mine because it indicates that the Earth was formed cool and didn't take thousands or millions of years to cool over, and that's always bothered me. Also, the moon dust and stuff like that would certainly be something interesting I'd love for you to look into.
Well, again, if it were scientifically valid, then scientists would ultimately come to accept it because that's what we all do. We look at the data and try to make sense of it. At the moment, that particular case has not convinced anyone.
Well, when you have time, look at Robert Gantry's discovery and see what it points to as far as the polonium halos of granite and the base rock.
That's your homework assignment. Thanks
Thank
for your
you.
phone call. Let's go to Bob. You're on News Radio 850 KOA. Hello, Bob.
Hello, sir.
Yes, Bob.
Okay. I find this quite fascinating, the universe and life, how it began. I've got a couple of questions or comments, and then would you please respond? But I find it irritating when I hear people say the universe is like 14 billion years old, when in fact, when they're just talking about what the Big Bang created, and we don't know for sure. Well, we don't know if it's more than 14 years, but our known universe is 14 billion years old. But we're just a speck in the big universe. Isn't that correct? The universe is infinite, and we're just a spot in the universe.
Well, that's something that we don't actually know. What we do know is that the universe that we observe, the galaxies moving apart from each other, started moving apart about 14 billion years ago, if you look at the evidence that we have today. We can't say anything about before that, and there's even debate as to whether the question of before is a valid question if the universe includes time. So what you're asking about are things that are outside of the realm of what science can currently study.
Right. I believe we're just like a speck of dust in the universe, and there's many. Then there's other big bangs going on all the time.
So we're a speck of dust in the universe, and the universe is a speck of dust in a greater universe, and that's certainly possible, yes. And I don't even know what the market's going to do tomorrow. How in the world can I know about that? All right, thanks for your phone call. Let's go to, where are we? Bob, you're on, excuse me, Bob's not there. Let's go to air, we haven't gone to Scott yet. Scott, you're on News Radio 850 KOA. Hello, Scott.
Hey, good morning. Thanks for your time. This idea of being at the edge of the universe, everybody struggles with, and I thought of something recently. I was listening to Alex Filipinko at the World Affairs Conference over in Boulder, and what helped me is to think about that, our matter, ourselves, our bodies are kind of a configuration of matter, and inside of that, or riding on top of that, are a result of energy. And all of the universe around us, the air around us, is all energy. And it would seem that at the end of the universe, that matrix of energy, that's the edge. And so you wouldn't see anything beyond it. You wouldn't be able to move your hand into that vacuum without some sort of consequence, because there's no longer that matrix of energy and balance and whatnot. What do you think of that, Jeff?
Well, I'm not quite sure exactly what he's referring to there, but Alexei Filippenko...
He did not come up with that. Yeah, I was listening to this very subject. Everybody seems to struggle with it, and I'm wondering, that's what helped me understand is that, there's dynamics that we are not thinking of when we talk about just waving our hand in the, into a vacuum.
I think the key, if anyone out there wants to understand this, what we think about in science about edges and centers and things like that of the universe, what you have to do is you have to first learn a little bit about Einstein's general theory of relativity. And there's a number of good popular books out there you can read about it. I have chapters on it in my college textbooks. I'm getting ready to write a book about it, but I haven't done it yet, so you'll have to wait for that one.
All right, thanks for your phone call. Right back on News Radio 850 KOA. 11:25 the time, 713-8585, our telephone number. Jeffrey Bennett, our guest, an astrophysicist. His book, Beyond UFOs, the Search for Extraterrestrial Life and Its Astonishing Implications for Our Future, which we've been talking about for the last hour and a half or so. You can go to Jeffrey's website, which is simply Jeffrey Bennett, 2 N's, 2 T's, jeffreybennett.com. There's another website, if you're making notes, go to beyondufos.com for more information about this book and its contents. Here's a philosophical question that's more at human nature than at the cosmos, and you make this point in your book, and it's hopeful. I wish I could be as... No, I don't wish I could be as optimistic as... I don't do a lot of wishing. I'm not as optimistic as you are, my notion of human nature. Talking about how study of this kind of thing and maybe what seems to be our innate urge to explore, as we've demonstrated on this planet and now beyond this planet with our trips to the moon and our various exploratory vessels that we've sent to Mars and toward Pluto, as you say, arguing for continuing to explore. You talk about setting up a research laboratory and a telescope on the moon. Then you say, imagine a world in which Arabs and Israelis, Chechens and Russians, Americans and Iraqis can all look up and say, we are working together up there, meaning on the moon, so surely we can work together down here. If we want to grow up, this is not just the world we must imagine, it is the world we must build. When we talked earlier about whether it's inevitable that civilizations will destroy themselves before they're able to get to the technological level such that they can explore interstellar space, that's obviously the key question. The history of the world has been a history of conflict and warfare. what evidence would you have that we can go beyond that?
Well, I like to point to two things, which I believe I discussed both in the book. One is, if you look at the history of weapons, you find that throughout history, every time we invented a new and more terrible weapon, we used it. You know, of course, the famous story of Alfred Nobel and dynamite. He thought it would make war impossible. It was so too horrible. And then we were using it in no time. But that actually changed with nuclear weapons. We built them, but we did not use them in a war between the Soviets and us. And I think it was because we're smart enough to realize, you know what? This time the stakes are too high and we better find a different way of doing it. So I think we did find a way to go beyond our historical urges, and I think that that gives me some hope that we can take the problems we have today and find a way to solve them. And the other one I like to think about, which Carl Sagan used to talk about, is the fact that until very recently in human history, slavery was considered perfectly acceptable. And in the past couple hundred years, we went from where slavery was acceptable almost everywhere in the world to it being considered completely unacceptable. And even those places where we know there is still some slavery today, they try to hide it because they know it's unacceptable. So we have gotten better as a species over time. We still have lots of problems. The question is, can we continue to get better without having the problems do us in? I believe we can.
Well, and that's a hopeful view of where we might go, and I don't want to rain on your parade. And I have no knowledge of the future either. One of the difficulties is, though, that collective we to which you refer includes some theys in it who don't think like we do. In this current conflict we have with Islamists, jihadists, with people who wouldn't be deterred by what deterred the Russians, this notion of mutual assured destruction, who are looking forward to a better life in the next world, are perhaps people who are more inclined to use nuclear weapons without any concern about the consequences in this here and now world.
That is a very scary thing. And I think there's two questions. One is, how do we prevent them from getting that now? So how do we stop the immediate threat? But the longer term question is, how do we make it so that people don't think that way anymore? And to me, the answer has always been education. In the book, I talk about what I call center of the universe syndrome, and the idea that there's some people who think they are the center of the universe, they know God's thoughts, they can do whatever they want to the rest of us. But if you learn about the real universe, the one that's so remarkable out there, the one that we're studying and exploring, you will start to say, you know what, there's much more out there than just us, and we need to learn to respect each other, live with each other, so that we can go and be part of this incredible adventure that's out there. And I believe that humans everywhere could learn that if they had the opportunity to learn it. Right now, they don't, but we can change that in the future.
How about the notion of solipsism?
In what sense?
In the sense that the only reality is what you think you're experiencing and feeling, and I don't necessarily subscribe to this, but I understand when people talk about it. The notion that talking about you right now, that you're the only one that really exists. Everything around you, everything that seems physical and temporal, is a figment of your imagination. It's called solipsism.
You know, it goes back to I think, therefore I am, right? And so there is, philosophers debate, is there an objective reality out there? I come down on the side of, yes, you drop something out of a building, it will fall because of gravity. So if there really is an objective reality, then we can all learn about it, we can all be inspired by it, and I believe that we will.
Let's go to Steve in Colorado Springs. You're on 850 KOA. Hello, Steve.
Hi, Mike.
Hi.
Great show. Doctor, you mentioned Sagan in your last discussion. As you know, Sagan was a disciple of Darwin's theory of evolution. He said evolution is a fact amply demonstrated by the fossil record and by contemporary molecular biology. Do you have a view on Sagan versus intelligence design?
Yes. I mean, I would say that me personally, I think that Sagan was correct on that. I look at the analogy with gravity. Gravity is a fact. If you drop things down, they will fall. We also have a theory of gravity that tries to explain why that is, and that theory has changed over time. We had Newton's theory of gravity, now we have Einstein's theory of gravity, and we know that that is incomplete because there's things it can't explain. In the same way, we think that evolution is a fact because we see the fossil record, we watch evolution take place before our eyes in the laboratory, Darwin actually did not come up with the idea of evolution. It goes back thousands of years before him. What Darwin did was come up with a theory to explain why evolution occurs. And that theory has been tested. It's been modified since the time that Darwin first proposed it. It will continue to be modified because we're learning more about it. But I think you have to distinguish between the theory that tries to explain it and what it is that you're trying to explain.
Do you believe that perhaps intelligence design should be taught in the schools as well as Darwin's theory?
You know, I talk about this quite a bit in the book. Intelligent design is an interesting idea, and I would say that's quite possible that it's true. I don't believe it should be taught alongside science because it's not science. Because in intelligent design, you're postulating that there is something that cannot be explained by science, that it was just done this way by the designer. And in science, we have to work from the assumption that we can understand things and go deeper. An analogy I like to use is building a bridge and a bridge that collapses. If the bridge collapses, it may be because it was an act of God. But if you use that as your assumption, you'll never have the opportunity to find out if it was something else natural that you might be able to do better the next time you build a bridge. So in science class, I think we have to stick to science. If you want to have broader philosophical and religious classes where you introduce other ideas like intelligent design, that's perfectly fine. But I think in science, we have to stay with things where we're looking for natural explanations.
But a lot of the people who want to introduce intelligent design in a science class want to do so precisely to challenge the science, to challenge natural selection, to compete with it.
That is what they're trying to do, but to my mind, they're doing it in a way by introducing. You could challenge it with creationism too, and the idea of a 6,000-year-old Earth, which some people believe from the Bible, and that to me is also a perfectly legitimate belief. I have no quarrel with anybody who says the universe is 6,000 years, and I believe that because it's what it says in the Bible. My only claim is that that's a conclusion you arrived at by reading the Bible, not by doing scientific research.
Oh, I understand, and we've done so many programs on this topic. It's my observation that intelligent design really isn't a theory, it's a rebuttal. The theory can be expressed in 5 seconds. God created everything. That's it.
Mm-hmm.
Steve, I'm guessing, and stop me if I'm wrong, that you'd be inclined to introduce intelligent design into school curriculum. Am I right?
Mike, that's absolutely right. I've read a book recently by Kepler. He said the chief aim of all investigations of the external world should be to discover the rational order and harmony which has been imposed by God. If you look at the vast majority of scientists, like Newton, Galileo, and Boyle, they also strongly committed to the existence of God because the reality of order was a product of a rational intellect. It just seems like today, with fashionable modern-day scientists and educators, they believe they'll pursue the truth wherever it leads, unless it leads to a special creator.
It's a very good point. And again, I'm not saying that it shouldn't be taught in schools. I'm saying it belongs in the philosophy classes that you teach in schools, where you talk about different ways of coming about knowledge. But in science, we need to stick to things that are observable and experimentally testable and are looking at natural processes.
When was that terminology introduced into the debate?
Which terminology?
Intelligent design instead of creationism.
It came up about, I think, around 95 or 96, and it was actually started by a couple of, I believe they were actually astrophysicists who had gone out and gotten their PhDs in astrophysics because they wanted to find whether science really supported their personal belief that the Bible and 6,000 years was correct. And in that process, they came to the conclusion that the evidence for an old universe was so strong that they couldn't claim that it was 6,000 years old. But they still wanted to believe that God was directing it, so they came up with this idea of intelligent design. And again, it's quite possible that it's true. It's just that it falls outside of the realm of science.
I've just observed that the term creationism, by people who believe in creationism, tends to have fallen into disfavor as a tactical term, and they use the term intelligent design instead because it sounds more scientific.
That's right. That's right. And also they tend to divide themselves according to whether they believe in a young Earth or an old Earth.
All right. Steve, thanks for your phone call.
Mike, thank you.
11:37 the time, 713-8585, our telephone number. Jeffrey was originally only committed to our 10 to 11 o'clock hour, and he's got someplace else to go. So I'd like to thank you for being with us today and for staying into this hour as well. The book, again, is Beyond UFOs, And you can go to Jeffrey's website as well, which is Jeffrey Bennett, BENNETT.com.
Thank you very much.
I'll take a break. We'll have another 15 minutes or so when we come back if you want to continue with this discussion. I cannot give you any qualified answers. The scientist is leaving the studio, but I can certainly shoot the bull with you right back on News Radio 850 KOA. 11:43 the time, 713-8585, our telephone number. Jeffrey Bennett was our guest during the last hour and 40 minutes, and Jeffrey, of course, is an astrophysicist. His book is Beyond UFOs. I am not an astrophysicist, although I sometimes play one on radio, so I certainly can't give you anything approaching the depth of knowledge or qualifications that Jeffrey has in this area. But we got into metaphysical discussions and other things, and try as you might to grasp the notion of infinity and space and time. And some people may get closer to grasping it than others. There are still so many unanswered questions that nobody can claim to fully understand this. And it's a constant reminder whenever we do a topic like this about how little we know, or certainly in my case, how little I know about it. Steve, you're on. This is the same Steve we have just from a moment ago. Steve, you're on 850 KOA. Is this Steve from Colorado Springs?
Hi, Mike. We chatted briefly about Darwinism. Just a couple brief comments. You know, the doctor mentioned that the fossil record supported Darwin. That really is not true. I mean,
well, you can assert that, Steve, but you're not going to persuade me on this, and you certainly won't persuade him. You probably believe that. There are some holes in the fossil record, and I've heard arguments that try to rebut it. But all I can tell you is whatever you're going to say is not something I haven't heard before, and you're not going to persuade me. But go ahead, you may persuade somebody else.
Okay. Well, Dr. David Berlinski, author and senior fellow at the Discovery Institute, based on some back-of-the-envelope calculations, said it would require about 50,000 changes for a single land-dwelling creature to evolve.
Yeah, I've heard that argument, and the Discovery Institute has an agenda.
They do, but the fossil record does not support that.
Okay, and I could deliver 75 scientists who would disagree with you on that and disagree with him, so...
Mike, my second point on this contemporary molecular biology issue, back in the 19th century, they just didn't have the high-powered microscopes we have today, and as a result, they've been able to go into the cell and see, what DNA is composed of, and something like that, frankly, did not evolve, over time. It really, I think, is a work of an intelligence designer.
Oh, you can believe that. And who is the intelligent designer?
Well, it'd be God.
Yeah, I understand. That's why when people use that term intelligent designer tactically to present themselves as offering a scientific explanation, and then can present the names of scientists who support them, right. The ones that are the slippery ones that I've had on this show before, even though they believe that it's the biblical God, the Judeo-Christian God, that is this intelligent designer, when they're being tactical, they won't answer that question. They'll finesse that question. I give you credit for being candid.
Mike, I heard I'll follow up with just one final comment. I heard somebody say the other day that if some of these modern-day scientists would see Mount Rushmore, they'd probably theorize the mountain was caused by rain, snow, and wind. Or would they recognize that a creator had a hand in the masterpiece? Just a final comment.
Okay. Somebody once noted that God created man, and man returned the favor by creating God in his own image. It's a profound or provocative thought. When the Bible tells us in Genesis that God created man in his own image, are we to believe then that God looks like man?
That's a great question.
Yeah, and if God is some omnipotent, impossible to fathom creator, and if there is such a God, I would imagine that's what he has to be, then what does the Bible mean when it said God created man in his own image if God doesn't look like that?
Right.
Not an answer to the question, I understand. That's a rhetorical
Mike,
question.
A final comment.
Yeah.
Your guest made a quick point about everybody getting along up in the moon.
No, not up in the moon. He said that if we continue to explore the cosmos and if we're able to work together on the moon, his point was that one of the benefits of that is that he said, let me read the passage. Imagine a world in which Arabs and Israelis, Chechens and Russians, Americans and Iraqis can all look up to the moon and say, we are working together up there, so surely we can work together down here.
Just one background note, Mike. I'm a retired general, served in the war against terrorism. I've seen evil. The only way you can deal with evil is to kill it.
I agree with you, and I think there is something that can be described or defined as evil here on Earth. And when Jeffrey, who's brilliant and optimistic about human nature being elevated, imagines a world in which Arabs and Israelis and Chechens and Russians are looking up there and saying, why can't we all work together down here? It's because some of those will say that down here doesn't matter, and you're an infidel, and that's why you must die, regardless of what's happening on the moon.
Exactly.
Okay, thanks for your phone call.
Mike, thank you.
713-8585, our telephone number. Let's go to Rupert in Broomfield. You're on News Radio 850 KOA. Hello, Rupert.
Oh, hi, Mike.
Hi.
This is a question that I've been asking myself. Recently, NASA and Themis, the spacecraft that's doing the magnetic field studies, have discovered that magnetic lines reconnect. If magnetic lines reconnect, this is brand new. This is changing everything from 150 years ago. I was curious to hear what he had to say about this magnetic line reconnection. I mean,
I'd be curious to know as well, but you certainly won't get any answer from that on me.
Well, they're always talking hypothetical, theoretical. Magnetism is real.
Yes, it is. Yes.
And they seem to never mention that. I mean, we know this is for real. This isn't computer modeling. This is for real. But this is, I think, a monumental announcement, and I haven't heard anybody mention it.
Well, it's way out of my realm of expertise, although I can recall this. For those who think that I'm not sentimental and unfeeling, I can remember when I was in geometry class as a kid. How old were you when you were in geometry class? 13, 14 years old, something like that? I remember I cried in geometry class when the teacher told us that parallel lines would never meet. I just thought that was so sad.
But I always like geometry better than trigonometry anyways.
All right. Thanks for your call. Right back on News Radio 850 KOA. 11:54 the time. Right back to the phones in Parker. Dave, you're on 850 KOA. Hello, Dave.
Hi, Mike.
Hi.
Hey, regarding the Genesis account where God created man in his own image, another take on that, which I learned a while back, was the fact that we're not created in the image of God in that we have two arms, two legs, that type of thing, but that we are eternal beings. Just as God is eternal, we are eternal as well. He made us like him in that regard. So sometimes people think, oh, is he the old guy with the long beard that sits up on a cloud?
Looks like Moses.
Right. And he definitely has appeared to us over the years as humans, but he's also appeared in lots of other ways. He appeared to Moses as a burning bush, and he appeared in the silence to the prophet. So, there's a lot of ways that he can appear, but he would obviously not.
Yeah, that's a possible interpretation, obviously, but why didn't it just say that in Genesis in so many words?
Well, I think it's probably our translation. I'm not a Hebrew scholar, but I think if you read the Hebrew, it's a lot more enlightening than reading an English translation of Hebrew.
Perhaps that's why the commandment, thou shalt not kill, is loosely translated from the original Hebrew. I've been told that it should read, thou shalt not murder, because there's a big difference between killing and murder.
Absolutely.
And the Old Testament God was certainly involved in killing that wasn't murder. But if you find thought-provoking that quote earlier of God created man in his own image and man returned the favor by creating God in his own image, it takes you to some consideration of the fact that the Bible, when it was actually committed to paper or whatever preceded paper, was written by man, perhaps inspired by God. And the men who wrote the various things that ultimately were consolidated into the Bible or just told the stories that were ultimately converted into a printed Bible took some liberties and some license. And perhaps they wanted to imagine that God looked like them.
Well, and obviously that is sort of the hubris of the human condition. We think we're very important.
Yeah, and that's the irony of that statement, which I've always found that statement interesting. The second part of it, you're exactly right, is an expression of hubris. If you assume, for argument's sake, that there's a supreme being that created man, then man turned around and created God in his own image.
Yeah.
Interesting. Okay.
Well, and you that's where you get into two schools of thought. You know, there's people who believe that every literal, you know, letter in the Bible is perfect, just as God intended it to be, and then there are those who believe that it is. You know, there's been some liberty, whether it was intentional or not, but that overall the Word is inspired and infallible to believe. So it may not be inerrant in every transliteration. Especially, I definitely believe that when you're talking about translations.
Mm-hmm.
If you really want to read the Bible, you should study Hebrew and Greek and Aramaic.
And, of course, it's certainly plausible that the Bible, among other things, is a collection of folklore, and that people who write folklore take some liberties, and that memories are faulty and get exaggerated or expanded over time.
But as opposed to the myth, well, not the myth, as opposed to the story of Gilgamesh from the ancient Babylonians, not a lot of people know the story of Gilgamesh.
I'm one of them.
Oh, well, there you go. That's good.
I'm one of them that doesn't know the story.
Oh, it doesn't know the story. Well, I there's no time to portray it here, and I wouldn't do it justice, not being a scholar. But my point is that being a myth, which it was, there's a heroic figure who has a lot of supernatural powers. Mm-hmm. That being a myth, that has a lot less bearing on our world today than what some people call the myth being the Bible. I think the proof is in the pudding, in that the Bible has a lot of influence and is still very valid for people to read and follow.
Okay, well, I certainly don't claim to have any answers in that regard. I do have a lot of questions. Thanks for your phone call. That wraps it for today. Got the news coming up, followed by Rush Limbaugh. Back tomorrow at 9. Stay with us. This is Mike Rosen. You're on News Radio 850.